Hello, in this video we're going to go through a couple problems where we find lengths using the sine ratio. Now it's important to point out that whether you use the sine, tan, or cosine ratio, it's the same idea. You know, a lot of the problems you do in textbooks, they tell you which ratio to use initially, and then the idea is that you get comfortable with it. But the next step you want to make sure you can do is, given any two sides, can you figure out which ratio to use? So in this question they tell us we're interested in using the sine ratio. So we remember that sine is the opposite over the hypotenuse. So this is the angle that I'm given. So again, I can confirm that if I go across, x is the opposite, and 13 is the hypotenuse in this case because it's opposite of the 90-degree angle. It's the longest side of the right angle triangle. So therefore we know that sine of 25 degrees, and don't forget that degree symbol. If you leave the degree symbol off, you're indicating a radian, is equal to the opposite, which is x, divided by the hypotenuse, which is 13. So I'll just write this up here. Sine of some angle, let's call the angle A, is equal to the opposite divided by the hypotenuse. So now sine 25 degrees is simply a number in disguise, so I want to get x by itself and then work out the value in one step on my calculator. So to do that, I'm going to multiply both sides by 13. So I get x is equal to 13 sine 25 degrees. So x is approximately equal to, and now I'm going to come over to my calculator here. So again, I'm sure those of you that watched a couple of my videos, I sound like a broken record now, but it's important. Make sure your calculator's in degrees mode. You can measure an angle using degrees or radians. You very well might not have studied radians yet, but your calculator could be in radian mode, meaning that you can get the wrong answer. So one way to check is to memorize that sine of 30 degrees is 0.5, 1 over 2. So whenever I get a calculator out, and if I'm not sure, I always take sine of 30 and confirm that in fact I am in degree mode, because I get 0.5. It's really important that you go and check to make sure you know how to change your angle measurement. So you see here I can be in radians or degrees, and I'm in degrees. So therefore, let's work this out. 13 times sine of 25 degrees equals, and we want this to the nearest tenth of a unit, so we get approximately 5.5. Okay. Again, really important, don't figure out what sine of 25 degrees is, write it out as a couple decimal places, and then multiply it by 13. Have your calculator do the work for you. Okay, let's do this next one. So this is the angle I'm working with. In this case, if we take a look, we see that 5.6 is the opposite, and x is the hypotenuse. So therefore, we know that sine of 66 degrees is equal to the opposite, which is 5.6 divided by the hypotenuse, which is x. So again, the algebra here is not hard, but it can give a little bit of a pause. So the first thing we're going to do is we're going to multiply both sides by x. And then what we're going to do is we'll divide both sides by sine 66 degrees. So x is equal to 5.6 divided by sine of 66 degrees. So x is approximately equal to, so we go 5.6 divided by sine 66 equals, so we get approximately 6.1. And again, I'm going to ask myself, does my answer make sense? Yes, it does, because it should be longer than 5.6. Okay, let's do one more problem, shall we? Let's work in green. So again, I'm working with the angle 50 degrees. 12 is the opposite, x is the hypotenuse. So sine of 50 degrees is equal to the opposite, which is 12 divided by x, which is the hypotenuse. So x sine of 50 degrees is equal to 12. So x is equal to 12 divided by sine of 50 degrees. So x is approximately, don't forget to put that approximate symbol, 12 divided by sine of 50. And we get approximately 15.7 centimeters. And then I ask myself, do I feel good about this? And the answer is yes, because 15.7 is larger than 12, and since x is the hypotenuse, that makes sense. I hope this video helped.